Hi, I'm Isha, and this is my video project. So I received example number 5, and the first problem of example number 5 says to use the intermediate value theorem to show that there is a solution to the equation cosine of x equals x, and on what interval must it lie? The second one is true or false, the intermediate value theorem can be used on f of x equals 1 over x on the interval -1 to 1 to show that f of x equals 0 somewhere on this interval. So we're going to focus on problem 1 first. So problem 1, we need to use the intermediate value theorem, which is abbreviated as IVT, to show that there is a solution to the equation cosine of x equals x, and we need to find the interval that this solution is on. So in order to do this, we need to know what the intermediate value theorem actually is. So the intermediate value theorem states if some function f is continuous on the closed interval a to b, and we let n be any number between f of a and f of b, where f of a isn't equal to f of b, and f of a is less than n, and n is less than f of b, then there exists a number c in the interval a to b such that f of c equals n. And this comes from chapter 1, section 8, which is all about the intermediate value theorem. So in step 1, we rewrite cosine of x equals x as a function of x, and then we set it equal to 0 in order to solve this and find a solution. So in step 2, we check the domain of f of x equals x minus cosine of x to see if there's anywhere f of x doesn't exist or if there's discontinuities, because we want to make sure that the interval that we're choosing, that f of x is continuous on that. And so after finding the domain, we see that it's -infinity to infinity, which means f of x is continuous everywhere, which means we are safe to pretty much choose any numbers for our interval, and we know that f of x will be continuous on those. So after finding the domain, we need to test an interval to see if f of x equals 0 there. So we take two numbers. I like the numbers 1 and 2, so let's make that our interval. We're going to test the interval from 1 to 2 inclusive. So we need to see what f of 1 equals and what f of 2 equals. So we're going to take our lower boundary first, f of 1, plug that into the function, and we get about 0.460 with some rounding. And then we take 2, we plug that in, and we get about 2.416. So then we check, and we realize that f of 1, which equals 0.460, is not less than 0, which was what our original function is equal to. So the interval from 1 to 2 will not work, and there's not a solution on that interval. So now we need a different interval. And we take another number. I think 0 is a pretty simple number, so we'll take that as our new interval, 0 to 1. So now we need to check. We're going to plug 0 in. We plug that into the function. We get -1. Now we're going to take 1. We plug that into the function. Again, we get 0.460 rounding. So now we're checked. So f of 0 equals -1, and that is indeed less than 0. And 0 is less than f of 1. So we are set there. And earlier we checked the domain. We found that f of x equals x minus cosine of x is continuous on its domain from -infinity to infinity. And we just found out that f of 0 is less than 0 and 0 is less than f of 1. So by the intermediate value theorem, there is some c value on the interval 0 to 1 where f of z equals 0. And that is the solution for our first problem. So let's move on to number 2. So for number 2, we were given a statement that said that the intermediate value theorem can be used for the function f of x equals 1 over x to find a solution on the interval -1 to 1. And we need to figure out whether that statement that was given is true or not. So step 1 of solving this, we're going to make sure that the conditions of the intermediate value theorem are satisfied. And so we're going to check the domain, and we find out that the domain of this function is -infinity to 0 and 0 to infinity. This function does not exist at x equals 0 because 1 over 0 does not exist. We cannot divide by 0. So then we're going to check our interval that was given to us. Our interval is -1 to 1, Well, 0 is on that interval, so that means that f of x is not continuous on this interval. So since f of x is not continuous on -1 to 1, the intermediate value theorem cannot be used to show that f of x equals 0 somewhere on this interval. So therefore, the statement given to us in problem number 2 is false. And that is all. Thank you.